Dear learners, Assalamu alaikum. Welcome you all to this very academic class on the topic equation. Our subtopic is quadratic equations of one variable and their solutions. That is, we are going to discuss about the quadratic equations of one variable along with their solutions. In fact, it is an attempt to derive a formula from the quadratic equation of the form ax square plus bx plus c is equal to 0 along with its solution, such that you the learners can solve any quadratic equation very easily by applying the formula. Let us start the next slide. Learning outcomes. Dear learners, at the end of this class, you will be able to evaluate formula from a standard quadratic equation of one variable. Use formula to solve quadratic equations of one variable. Prior knowledge. If you're going to start the main speech on the topic, I should say quick in understanding of your previous knowledge on the following three subject specific vocabulary. Number 1, equation. Number 2, degree of equation. Number 3, root of equation. At first, equation. The equality of two expressions is called equation. As for example, twice x is equal to 3, x square plus twice x plus 1 is equal to 0, x cube minus 1 is equal to 0, etc. Next, degree of equation. The highest power of the variable in an equation is called the degree of the equation. As for example, x to the power 5 minus 1 is equal to 0 is an equation of degree 5, as the highest power of the variable in it is of degree 5. We may also see the above three examples of equations. Twice x is equal to 3 is of degree 1 or linear equation. The highest power of the variable in it is 1. X square plus twice x plus 1 is equal to 0 is of degree 2 or quadratic equation, as the highest power of the variable in it is of degree 2 or is of power 2. X cube minus 1 is equal to 0 is an equation of degree 3 or cubic equation, as the highest power of the variable x in it is 3. Number 3, root of equation. The value of the variable in an equation which satisfies the equation is called the root of the equation. As for example, x is equal to 1 is the root of the equation, x square minus 1 is equal to 0. As x is equal to 1 satisfies it, x is equal to -1 is also another root of this equation. We know every equation of degree n has exactly n roots. That's why every equation of degree 2 has exactly 2 roots. And for this obvious reason, x square minus 1 is equal to 0 has 2 roots. X is equal to 1 and x is equal to -1. Main speech in the topic, quadratic equations of one variable. The standard form of a quadratic equation in variable x is ax square plus bx plus c is equal to 0, where a, b, c are real numbers and a is not equal to 0. The question may be arising in you, why is a not equal to 0? So learners, pay your attention. If we put a is equal to 0 here, then the equation ax square plus bx plus c is equal to 0 becomes bx plus c is equal to 0, which is certainly linear equation or an equation of degree 1. But our topic is of quadratic equation. That's why a can never be 0. Second question may be arising you at the time of solving quadratic equation. Any quadratic can be solved by the process of factorization. For making your understanding clear, listen to me what I say. We cannot solve all types of equations of this form by the process of factorization, such as x squared plus x plus 1 is equal to 0 can't be solved by factorization. That's why we have to follow the following procedure to solve the quadratic equations of any form. In order to solve the quadratic equation 1, we should multiply both sides of it by 4a. And after multiplying by 4a, we get 4a square x square plus 4abx plus 4ca is equal to 0. You must ask, why is it multiplied by 4a? We have multiplied it by 4a to make the solution easy. This equation can also be solved by dividing a. However, 4a square x square can be written as twice ax whole square. 4abx can be written as 2 into twice x into b. To make a formula of whole square, we have added b square on both sides. And the term 4ca is transposed from the left to the right by changing its sign. As a result, it becomes twice ax whole square plus 2 into twice ax into b plus b square is equal to b square minus 4ca. This equation will be twice ax plus b whole square is equal to b square minus 4ca. Since we know a square plus twice ab plus b square is equal to a plus b whole square. Since this equation 1 is to be solved, that is, the value of x is to be found, that's why we should take square roots on both sides, or square rooting both sides, we get twice ax plus b is equal to plus minus square root of b square minus 4c. Transpose the term b from the left to the right, then you can easily have twice x is equal to minus b plus minus square root of b square minus 4c. And then dividing both sides of it by twice a, we can easily have x equal to minus b plus minus square root of b square minus 4ca by twice a. Therefore, the roots say x1, x2 of the quadratic equation are x1 is equal to minus b plus square root of b square minus 4ca by twice a, and x2 is equal to minus b minus square root of b square minus 4ca by twice a. This formula is very much important to solve any type of quadratic equation. Let us see with an example. Example 1. Solve 3 minus 4x minus 2x square is equal to 0. This question may be asked in another way. Find the roots of the equation 3 minus 4x minus 2x square is equal to 0. Solution. The given equation is 3 minus 4x minus 2x square is equal to 0. And the solution of any quadratic equation. In case of solving any quadratic equation, we should express first in the standard form. That's why these equations should be expressed in its standard form. then it will be minus 2x square minus 4x plus 3 is equal to 0. Since there are two minus symbols and a single plus symbol, we should multiply both sides of it by minus 1. Then it will become 2x square plus 4x minus 3 is equal to 0. Which is already expressed in the standard form. This form of equation will always be compared with the standard equation ax square plus bx plus c is equal to 0. Dear learners, see, 2 is the coefficient of x square here, and a is the coefficient of x square here. Similarly, we can associate 4 with b and minus 3 with c. Then we can easily have a is equal to 2, b is equal to 4, and c is equal to minus 3. We know the roots of the quadratic equation ax square plus bx plus c is equal to 0 are ax equal to minus b plus minus square root of b square minus 4c a by twice a. Just we should replace the values of a, b, and c here. We can easily write. Therefore, the roots of the quadratic equation 3 minus 4x minus 2x square is equal to 0 are x equal to minus 4 plus minus square root of 4 square minus 4 into minus 3 into minus 2 by 2 into 2. 4 square is equal to 16, and the product of minus 4 and minus 3 and 2 is equal to 24. That's why it will become x equal to minus 4 plus minus square root of 16 plus 24 by 2 into 2. 16 plus 24 can be written as square root of 40. Square root of 40 is equal to square root of 4 into 10 is equal to 2 root 10. That's why you can easily write x is equal to minus 4 plus minus 2 square root of 10 by 2 into 2. We may take common 2 from the numerator, and there remains minus 2 plus minus square root of 10. Cancelling the common term 2, we can easily have x equal to minus 2 plus minus square root of 10 by 2. Therefore, the required roots of the quadratic equation 3 minus 4x minus 2x square is equal to 0 or x equal to minus 2 plus minus square root of 10 by 2. In this way, we can solve any type of quadratic equation by using formula. To make it clear more, let us consider another example. Show that the roots of the equation x square minus 14x plus 48 is equal to 0 are unequal and integral. In case of integral, the term natural is given, then we can solve it the same way. But rational, irrational, or real is written instead of integral, then the same question can be solved in another very easy way. It will be discussed in our next class. However, you can solve this equation here. The given equation is x square minus 14x plus 48 is equal to 0. This equation is already expressed in its standard form. That's why we should compare it directly with the standard equation x square plus bx plus c is equal to 0. And in the same way, we can have a is equal to 1, b is equal to minus 14, and c is equal to 48. And we know that the rest of the quadratic equation ax square plus bx plus c is equal to 0 are ax equal to minus b plus minus square root of b square minus 4ca by twice. Just put the values of a, b, and c. Then you will get the roots of the quadratic equation. X square minus 14x plus 48 is equal to 0 or x equal to minus 14 plus minus square root of minus 14 whole square minus 14 minus 4 into 48 into 1 by 2 into 1. Therefore, the roots of the quadratic equation x square minus 14x plus 48 is equal to 0 are x is equal to minus 14 plus minus square root of minus 14 whole square minus 4 into 48 into 1 by 2 into 1. It can be written as x is equal to 14 plus minus square root of 196 minus 192 by 2. And it becomes x is equal to 14 plus minus square root of 4 by 2. And it is equal to x is equal to 14 plus minus 2 by 2. If you consider the minus sign, then you will get x is equal to 6. And for the plus sign, it will be 8. Therefore, you can easily say the roots of the quadratic equation x square minus 14x plus 8 is equal to 0 are unequal and integral. Because 6 and 8 are integral and 6 and 8 are not equal. Special task. Number 1, find the values of x. Px square plus qx plus r is equal to 0. We have already done in case of a, x square plus bx plus c is equal to 0. If you practice it, then any set of quadratic equation will be made easy for you. Second one, use formula to solve the equation thrice x squared plus 7x plus 1 is equal to 0. You have also done two equations like this. Just this question is asked in a different way. I think it will be solved by all of you, inshallah. Dear learners, if you have any query, any question, please write me. It will be very seriously taken to solve for your betterment. The name of the topic for the next class is Nature of the roots of a quadratic equation of one variable. Thank you very much. Best of luck. With this, I conclude here.